graphing. You know that graphing is limited, whereas substitution always works. I'm going to teach you a third way that a bunch of you are going to say, this is way easier. I wish you taught us that first. That's fine. First thing we are going to do is remind ourselves how to solve a system by graphing. So everybody take that system and solve it on this graph. While I am setting mine up, it should take you not very long. So there should be 2 lines coming up on everybody's page pretty quickly, because that shouldn't take very long. Yeah, I did the slope backwards, thank you. So what is the solution to that system? Does everybody have a solution? You should. It shouldn't have taken this long to graph it. I don't care. 3, -4. Pick a number. No one's going to bother doing it, so I'm just going to do it. I'm picking 2. In a class where kids did something, I would get you to do this by yourself, but I'm just going to do it. Multiply both sides of the second equation by 2. 2. 5x minus 3y equals 27 times 2. which is 10x minus 6y equals 54. Solve for y. Negative 6y equals negative 10x plus 54. Divide by 6. Y equals 10x over 6 plus 9. Minus 9. 10 over 6 is the same as y equals 5/3 x minus 9. What you notice, if I ask what you notice, I will sit here for a minute while nobody says anything, so I'm going to tell you what you noticed. What you noticed is you get the exact same equation. So what does that tell us? Multiplying both sides of a linear equation results in a new equation that will graph the same line. In other words, it only changes the looks. You can multiply it and nothing changes except the looks. Turn on to page 237. If I add these equations, what is 4x's plus 5x's? 9x's. What is 3y's plus negative 3y's? 0y's. What is 0 plus 27? 27. X equaled what? 3. Now, it says put this new equation on the graph that we just made. Don't bother, none of you are going to. There is where x equals 3. What do you notice about the line x equals 3? Don't worry about it. No one's going to answer. It goes through where the solution is. No, I'm serious. Don't bother. I'm just going to talk because I'm tired of it. I know you know. It goes through the solution. What else did you notice? In the system, there were 2 unknowns. What happened when I added them? We got down to 1 unknown. What happens? We eliminated an unknown and got another line through the solution. Now, we're going to subtract them. What is 4 minus 5? Negative x. What is 3 minus 3? Positive 6y. What is 0 minus 27? Negative 27. And then if I were to graph this, which I'm not going to bother doing, where will the line go? Do you think? Of course it will go through the solution again. So adding or subtracting 2 linear equations results in a couple of things. Results in 1, a chance to eliminate a variable, and 2, it results in new equations that share the solution. Which means we can do stuff to our system and still get the same answer. When you look at something in math and you don't like what it looks like, normally you're stuck with it. You have to do something to that. But in this case, you can make it so the work you have to do is easy, because adding, subtracting, and multiplying all allows you to change the system to be easier to work with. So here I have two equations in a system, which means somewhere on the Cartesian plane like this, those two systems are going to cross, and that will be the solution. I want another equation that will share that solution. Any other equation that will share it. So we look back at what we see, and we see, okay, if I multiplied, it wouldn't change it. So I could multiply these by any number, and it would work. I could multiply these by any other number, and it would work. I could add them, and it would work. I could subtract them, and it would work. It doesn't matter. All of those equations would give me the same exact solution. That's all you have to take away from this. Now, if you turn the page over to 238, you will see what you need to do to solve by elimination, which is the third method. Step 1, step 2, step 3. Step 1 says add or subtract the equations to get rid of one letter. Well, if you need to get rid of a letter, that means there needs to be a 0 in front of it, correct? So that means there must be two equations that have the exact same coefficient. Is there? Yes. 5 and 5. How will I make that y disappear? Will I add or subtract? Obviously, I will add, because -5 plus 5 is 0. So when I add, I get 7x plus 0y equals -9 plus 23 is 14. That is step 1. I have added the equations to eliminate a letter. Would I write it this way? Of course not. I would write 7x equals 14. Step 2, which I am going to work in blue, like I numbered it in blue. Solve for the remaining variable. Well, since I have eliminated y, I only need to solve for x, which means dividing by 7. X equals 2. Step 3 is exactly like substitution. Take that, because x equals 2, and put it back into anywhere you see an x. Can I put it there? Yes. Can I put it there? Yes. It does not matter. I am going to use the first one. 3, not x, 2 minus 5y equals -9. 6 minus 5y equals -9. -5y equals -15. Y equals 3. What is my ordered pair now? X is 2, y is 3, and the last step is always to check. 3 times 2 is 6, 5 times 3 is 15, 6 minus 15 equals -9, so I am good. Then I check the other one. 4 times 2 is 8, 5 times 3 is 15, 8 plus 15 equals 23, so I am good. Any questions? Of course not. We will move on. Go to the next page. Not next page, I lied, just the bottom here. I have given you yet another hint. Sometimes it will not be that easy. The equations you have to look at will not match up. But fortunately, we as a class did a whole example of how you can change the way an equation looks in order to make it easy to work with. So let us look at these two equations. Are there two coefficients that are the same? No, there are not. So one of them must need to change its looks. Which one? Should I work with number 1 or should I work with number 2? Number 1 makes more sense because it has smaller coefficients. If I multiply this by 2, what will happen? I will get 2x minus 4y equals 14. What do you see right there? You see two of the same coefficients with a different sign, which means if I add them together, which I will do in red because it is step 1, if I add them together, y will disappear. 3 plus 2 is 5x. 4 minus 4 is 0y. 1 plus 14 equals 15. Then I will solve for x because I have eliminated one of my variables. So I will divide both sides by 5 and x will equal 3. Once I have x equaling 3, I can take that x and I can put it anywhere I want up there. I'm going to use the first one. 3 minus 2y equals 7. Negative 2y equals 4. Y equals negative 2. Then I know my ordered pair, which is 3 and negative 2, and then I check. Is 3, negative 2 times negative 2 is positive 4. 3 plus 4 is 7, so I am good. 3 times 3 is 9. 4 times negative 2 is negative 8. 9 and negative 8 is 1, so I'm good. Then I move over to the last one. The last one is doubly problematic. Why? Because neither of them works together. But you all already know what to do with that. If I ask you to add 1/2 and 1/3, how would you do that? You would know it would have to be 1/6, which would mean you would have to multiply this guy by 3 and this guy by 2. And then you would have a common denominator of 6. Well, since you need the same number and you have 3 and 2, would it not work to multiply this guy by 2 and this guy by negative 3? Then what would I get? Then I would have 4x minus 6y equals 40, and negative 33x minus plus, sorry, I should have used plus there. Plus 3, 33x plus 6y equals negative 3. Then I would combine them. 4 plus 33, 37x. The y's eliminate. 40 minus 3 is 37. X would equal 1. I should have done that in blue. Then I take that 1 and I take it back to any x I want. 2 times 1 minus 3y equals 20. 2 minus 3y equals 20. Negative 3y equals 18. Y equals negative 6. Then, of course, my ordered pair is 1, negative 6. And all I do is sub it in. 2 times 1 is 2. Negative 3 times negative 6 is 18. 2 and 18 is 20. 11 times 1 is 11. 2 times negative 6 is negative 12. 11 minus 12 is negative 1. And I would be done. Do your work. Starts on page 239. And there is a puzzle sheet to go with it. You will be having a quiz on all 3 methods tomorrow.
Tomorrow?
Yes, tomorrow. Because nobody bothers talking to me, so I can only assume everybody gets it. Therefore, it's time for a quiz.